Everyone, here I have an inverter circuit that I made using small quarter watt resistors like these and small audio transistors like these. I decided to make this circuit because many of the inverter circuits that you see online are made out of high-powered MOSFETs and center tap transformers. While these circuits are definitely more efficient than mine, I think it is still useful to create this circuit in scenarios where you don't have access to these components. Simple transformers and audio transistors are much easier to find and scavenge, and it's a great exercise for those just getting into the field of electrical engineering. Here we can hear the slight whine of the transformer, and we can see it working. It outputs roughly 250 volts AC or 280 volts DC when rectified. Today I will be talking about this circuit and tips and tricks for replicating this yourself.
So here's the basic circuit. Here I have an astable oscillator which, with its output fed into a transistor which is in series with a regular transformer. I won't go too much into the astable oscillator here because there are already many great resources on this topic. But the general idea is that the opposite transistor steals all the current for itself, which causes it to turn off. This happens in the pattern, and these two capacitors help maintain the base current so that these transistors can turn off for a very short period of time. The frequency of this square wave oscillation is determined by how fast the capacitors charge up to the maximum voltage. If you increase the ratios of R4 to R1 and R3 to R2, the frequency rises. The frequency also rises when you decrease the capacitances of C1 and C2. The duty cycle of this oscillation is given by the ratio of C1 to C2. We can see that the output of one half of this oscillator is connected to a transistor that controls the current through this transformer. Realize that most of these components aren't actually by themselves, and I'd rather place many small resistors and transistors in parallel to distribute the current.
So here's the oscillator in real life. I have replaced both R1 and R2, each with two 2.2 kilo ohm resistors instead of a single 1 kilo ohm resistor, because placing a single kilo ohm resistor heats it too much and it eventually explodes. Should add that both R3 and R4 are each 100 kilo ohm resistors and can be placed directly since not a ton of current flows through them. C1 and C2 are each 100 nanofarad capacitors, and this entire circuit oscillates at a couple of kilohertz. I have to oscillate this circuit at a much higher frequency than 60 Hz because I'm running it at a much lower amperage and therefore smaller magnetic field. This output of the oscillator is connected to 14 BC337 transistors and a single 2N3904 transistor. The emitter of each of these transistors is connected to a 47 ohm resistor to limit the current through each of these small transistors. More transistors would have probably been a good thing, but I ran out of space on this breadboard, and I didn't want to use another one. When the transistor is on its on state, the current is allowed to flow through this blue wire, through the transformer, and through this yellow wire, and eventually through this transistor. That's all for today. See you next time.